But yeah, let's go to the content. I hope that you have at least had some time to go through the material, looking at the videos and reading through this this material for these elements of cloud and cybersecurity part. So there are different units here. Let's start with the introduction to cybersecurity. So that covers basically basic concepts of cybersecurity. And of course, like in everything, it's important to understand the basics before you start building the more complex stuff. That it's important to understand, for example, that we have quite different aspects of security. So cybersecurity is, of course, one thing that we focus on now, but we also have other information security. And in cybersecurity, we have different aspects like network security. So making sure that the communications that we have between devices is secure, for example, and there are no denial of service attacks and so on. And application security is, for example, making sure that the code that we are producing is secure and yeah, so there are, of course, different specializations in security, and it's very difficult to master all of them, but it's important to have general understanding that there are these different type of security specializations that can be quite different in what sort of skills you have to learn. And it's good to also read these boxes that are sort of optional. Then there can be quite important things there as well, like basics of staying safe. I think this is something that everybody can, of course, use in their daily life to make sure that their home devices are secure. So it's good to read through those as well. And if we then go next to the terminology, it's important to understand these basic concepts like what is cyber attack and different concepts about security events and attackers, and also to understand that not all the risks are about attacks, because risks can be something that happens on some sort of human error. For example, if I configure something without understanding what I'm doing, I might be doing some mistakes, like exposing private information just because I have configured some network ports incorrectly, for example. So it's important to understand that there's not like hackers or attackers in all the risks involved. It might be something like human error or mistake or just some malfunction of something. But yeah, definitely important to understand that there are these attackers as well, and there are criminals, and then there's different motivations, like nation states can have political motivations, for example, and usually they have a lot of resources to develop attacks, whereas some attackers can be like organized crime, so they are only the only motivation is financial, so that they are trying to make money, so making phishing attempts and trying to do ransomware attacks, basically trying to get money out of it. So yeah, there are different criminals and different motivations, so it's good to understand that. And one very common and very key principle in in cybersecurity and any security is this CIA triad. So these are the most fundamental protection goals in cybersecurity. So the aspects that you want to make sure that are covered. So confidentiality, basically making sure that information is only visible to the right people. Integrity, so making sure that information is only changed by the right people or processes. And availability, making sure that the information is visible and accessible whenever needed. And it's not necessary that that all of these aspects are always important. For example, probably I want to make sure that my financial data is confidential and it has integrity, so that nobody is changing my financial information or bank account details or anything like that. Whereas some information is public, so confidentiality is not important there, but it's important to make sure that there is integrity and availability, so that nobody has tampered that information, but not necessarily important that it's confidential always. But these are the most fundamental protection goals of any system. And there are also some exercises related to these, but let's skip them for now, but might be useful to read those to memorize things better. And continuing with the basic terminology, it's important to understand the concept of threat landscape and that there are different attack vectors. Those are maybe they sound a bit complicated, but I think the concepts itself are quite simple. So that attack vector would be an entry point or a route for an attacker to gain access to a system. So it's, in a way, the concept is quite simple, even though the word is a bit complex sounding. And then there's also examples of different security breaches, like social engineering attacks, so that not, for example, all the security breaches have some sort of hacking involved. For example, I can trick somebody to give me their username and password, and that would be not like a hack technically. It's that I'm tricking somebody to give their credentials. And well, I think those concepts that I mentioned are quite important to understand. And malware is, of course, I think there's examples of different type of malware, and for example viruses and worms and trojans, and it's important to understand, at least on a high level, what this mean and what are the differences. For example, that worm doesn't need any user action to spread itself across systems, whereas virus can be the most common term. But yeah, it's important to understand what is malware and what are the different types of malware, at least on a high level. And then there's this talks about phishing, even though this is under malware, interestingly, but it's good to understand this phishing, although maybe this is something that nowadays it's quite common, at least on the media, that you read about different phishing scams on the wild, targeting different banks and also public services in Finland, for example. So phishing concept is probably quite common. but good to understand what it means. And the next part is these different mitigation strategies. So this is very important. So we all know that there are many different threats, but then how to actually prevent those risks from realizing. So this, I think, is good to understand. What are some of the capabilities? And in general, I think it's very important to understand that there is no one single silver bullet, so to speak, so that usually we have to have different layers of protection. Some call it like this onion principle, for example, that you have different layers, that if one of the layers fail, you have other controls to protect you. So that's why it's important to have different aspects, because you might have multi-factor authentication, but the attacker might use some other methods, and then the multi-factor authentication might be useless. So unfortunately, the attackers can be quite tricky. So they always try to find the easiest way to get in. So you must have these different type of controls to protect. So it's important to understand that. And very, very important to, of course, understand that educating users is quite important, because if we think about this phishing attacks and malware, no matter what kind of authentication methods, for example, we have, if the user is somehow tricked into using their credentials and clicking some suspicious links or opening attachments, then there is probably no sure 100% sure method of protecting in this case. So it's important to understand that educating users what kind of links not to click and what kind of attachments not to open in emails, for example, it's very important aspect of mitigating threats. And also this concept of threat intelligence is maybe good to at least understand the term that there are, for example, services that analyze what kind of attacks are on the wild, because usually there are different campaigns that are happening. For example, some of these nation states are, for example, using specific type of vulnerabilities in their attacks, and they might be targeting specific type of organization like defense or public services. And threat intelligence is the type of information that is gathered, for example, which groups are active and what kind of vulnerabilities or attacks they are actually executing. Okay. And as if any points you have any questions, you can open your mic and ask away. In Finnish or English is fine. The next unit here is the cryptography, and cryptography can be very complex, and especially all the maths that are behind that. I don't understand much about this, but it's important to understand the concepts of cryptography and what it can be used for, like encryption and hashing and so on. So in this unit, encryption is explained quite well that there's this plain text, that is the message or text that is encrypted. Well, it could be something else like pictures, for example. And when it's encrypted, it's this ciphertext. And there are different encryption algorithms, and I think in general it's good to at least know what are the most common algorithms like AES and RSA and those, and understand the concept that there's this shared secret key, that when I want to exchange information with somebody, I'm using the same key to encrypt and decrypt the information. But the challenge here is, of course, that I need to be able to share the secret somehow to others so that it's not exposed, because if somebody else has the secret key, then it's not secret anymore. And yeah, so that there's a description that the key exchange is then quite complex when we have more entities involved. So I need to be able to securely share the secret with all the participants that I want to communicate with. So that's where this asymmetric encryption comes. And in that case, in asymmetric encryption, basically everybody have this private key and public key, and private key is something that must always be kept safe. I will never share it with anyone, whereas this public key is something that I can share with anyone. And the concept is quite different compared to this shared key encryption. And here's an explainer how it works. So if I want to share some information and encrypt it, I will use my private key to encrypt it, and the other participant, well, I think I actually explained it a bit wrong, but yeah, so I will actually use the other person's public key to encrypt it, and then it can be encrypted only with that person's private key. Yeah, so that's how it works. And then I can use the public key to validate that. If I can use that to validate the integrity, basically. But yeah, it's probably good to read this through to understand the concept, how this works, and in general, I think with this asymmetric key encryption, it's important to understand that this is something that is usually used for key exchange, because it's a secure way of sharing these shared encryption keys with others. Because traditionally, this asymmetric key encryption was something that was quite, it takes a lot of computational power, so it was not feasible to encrypt everything with this asymmetric key encryption. Instead of sharing all the information through asymmetric key encryption, we would only share these keys with other parties. For example, in Wi-Fi, it works like this, so that asymmetric key encryption is used to share this secret key in a session, basically, that is used when communicating with the with your Wi-Fi base station, basically. So that's a very simple explanation, but yeah, it's good to understand this asymmetric key encryption and where it's used. And then there's some examples about these types of encryption. So these DES or triple DES, which is not considered very secure nowadays, and this AES is then that is probably the most common one that has basically replaced this DES and triple DES in most places. And this RSA is an example of this asymmetric encryption. And the next part is about use cases for encryption. There are good examples of cases where encryption is used, like in web browsing. Here I have this HTTPS and this padlock icon here. So that means that the connection is secured, and nowadays basically all the websites are using this HTTPS to encrypt the communication. And that's an example of encryption in transit. So the communication is encrypted, whereas other concept is encryption in encrypted at rest. So when data is stored, it's encrypted, for example, in devices like if you have your work laptop, usually they use something like Windows BitLocker to encrypt the hard drive. And also many message applications nowadays also they encrypt messages, like Signal, for example, that uses end-to-end encryption of your messages. So nobody is able to eavesdrop your communications. And then there's also some exercises if you want to test how this encryption works. So there's guidelines how to encrypt data with these web-based tools. And the next concept related to cryptography is this hashing and digital signatures. So good to understand both of those concepts. And basically there's an explanation how it works and what is the use case. So that can be used, for example, in quite many sort of business use cases where you need to prove that some documents have not been changed, for example, in a digital manner. So basically, we also use this public key infrastructure for that as well, at least in most cases. But it's good to understand what are these digital signatures, and also this hashing. That this hashing is like one-way function that if I have a document or something, I can calculate this hash out of it, so it can generate this unique sort of signature value out of that document, for example. And so it doesn't use keys, so it's a bit different than encryption, and it's never possible to turn this hash value back into this original plain text in this case, whereas in encryption you can decrypt the document with the key and then you get back the plain text that you had. But these hashing functions have their own different use cases. For example, I can ensure that if I download a file from internet, sometimes there's this hash value visible, and after I have downloaded it, I can then calculate the hash value again to make sure that the file, the integrity has been preserved. Nowadays, it's not that much a problem, but back when I was young and we had the dial-up modems, then that was sometimes the case that files got corrupted when you downloaded them. But hashing would be, for example, a solution for that case. But there are also many other use cases where you want to make sure that integrity is preserved on a file, because if even like one bit is changed on this file, then the hash value will be different. And this digital signature I already explained. And yeah, it's good to understand these digital certificates as well and what it can be used for. So it's also related to this encryption of communications and in this case, I think it's good to understand this concept of certificate authority. So some party that is trusted by all, so that it can be trusted by different parties and then used to sort of prove authenticity in a way. Yeah, it's good to understand these digital certificates as well. It's very common, at least related to this communication encryption. And the next part is networks and devices. So it's probably good to understand at least the basics of networks, which is nowadays, of course, quite basically everywhere. But there are also some concepts like switches and routers that might not be known to everyone, but it's good to understand those concepts and things like client server topology. I would say that maybe that's also something quite common, quite important concepts in a way to understand how the communication between different devices work, and that there are different protocols nowadays, the TCP/IP or UDP instead of TCP. In some cases, it's the most common. There are also some exercises that I cannot open because I haven't clicked all the previous ones. But yeah, also good to understand that there are different devices, obviously, but even those other devices nowadays are networked and usually those devices are using TCP/IP or UDP protocol, for example, and also some of those devices are using your regular operating systems like Android or Windows, and also those devices can have vulnerabilities, and those devices can also add risk into your network. It's good to understand that. And in this network unit, there's some terminology related to the protocols, for example, these datagrams or packets more commonly, and concept of IP addresses. I think it's important to understand the basics of basic concept of IP addresses and IPv4 at least, and DNS, depending on how much you actually work with configuration and so on. But it's good to understand at least on a high level what these mean related to networks. But this IP protocols and routing, for example, it can be quite complex and large topic. But if you work more on a sort of technical or infrastructure role, then it's probably good to understand this at least. And on the next page, we have some network and device related threats. Well, man in the middle attacks are at least good to understand the concept that if I'm communicating with another party, there might be somebody that is actually listening to the information. So it's eavesdropping or wiretapping basically, and in this case the confidentiality of the integration, the confidentiality of the information is compromised because somebody is able to listen to our secrets, but also they might be able to change some of the data, so compromise the integrity as well. And DDoS or distributed denial of service, or even just denial of service, is very important to understand that concept, because that is some quite common nowadays, that there are, for example, some nation states that target public services, for example, trying to disrupt the infrastructure, trying to affect the public services or how people are able to use those services. So it's very important to understand that concept. So it might be something like just bombarding the network with many simultaneous requests, or it can be also using some sort of protocol level vulnerability in some cases to cause this availability issues basically. And then there's some videos also of those examples. And on devices, there are different examples that, for example, file-based attacks like malware, or different types of malware that can be downloaded, for example, or somehow enter any of these devices, or also some these network devices like home assistants. There might be some sort of device-related threats as well. Yeah, so there are quite detailed explanations of different device vulnerabilities. At least on a high level, it would be good to understand that basically any connected device can be vulnerable, but not necessarily. You don't probably need to understand that well how the vulnerabilities work, because there can be many different ways how somebody is able to install or how those vulnerabilities can be realized. And then on the next part, there's some methods that you can use to protect your network. For example, firewalls is important, of course, to limit the network traffic. For example, well, antivirus, I would maybe consider it a network protection, but for devices, of course, that's one part. Network access control, splitting your network into parts. Well, we also have this in the next sections related to the zero trust. I think on the interest of time, we should maybe go this a bit quicker, but there are also some tips on protecting devices, for example. And the next unit is about authentication and authorization. So it's important to understand those concepts. So authentication is basically proving who I am, and there can be different methods: username and password, or PIN, or some something that that I have, like some sort of physical device, or something I am, like biometric authentication of different nature. So there are different ways of authenticating, and single factor, where I'm using, for example, just username and password, and multi-factor authentication, which is nowadays becoming the standard. So I'm using some additional factor, like a third factor there, to authenticate, like an authenticator app or something else. And with authentication, it's good to understand that there can be different attacks. For example, if I'm using weak passwords, somebody could just guess my password or use this brute force attack. So basically trying many guesses of the password, but usually all the systems have some sort of threshold that if I'm trying 10 different passwords for a user account in 1 minute, then I will lock the account for 24 hours, or this sort of protection. But there are also more advanced methods of attacks, like dictionary attacks and credential stuffing. So those might have higher probability of success. So at least it's good to understand that there are different attacks. This brute force is probably something that is most discussed about, but this dictionary is nowadays quite commonly used, and this credential stuffing, it's good to understand that concept as well. And this social engineering, we already discussed about phishing, but it's important to understand that this is quite common method, especially this phishing. And well, I don't think pretexting is so often discussed about, but it's important to understand the concept. And after authentication, the authorization is important concept as well. So for example, after I have been authenticated, then the next part is deciding, for example, what sort of resources I should have access to. And there are, of course, different methods in applications to manage the entitlements or permissions, what kind of things you have access to. And within the Microsoft ecosystem, this conditional access is quite important concept, not necessarily maybe for this course, but basically it's a way of making these conditions that in different conditions you might be, for example, required to do this multi-factor authentication. For example, if I'm accessing some applications that are quite risky from my home network, then I might be enforced to do this multi-factor authentication. Whereas if I'm accessing those from my office network, then I would be able to open those applications with just username and password. So a simple example, but that's what it means in brief. And this least privilege access is quite important concept also, so that whenever we are granting permissions for users, we should aim to be only giving them the level of access that they need, because there's always some risk that if users are given additional permissions, then they might, for example, misuse them, or if their user account is compromised, for example, then an attacker might be using those highly privileged permissions. For example, if I have some administrator permissions, the attacker might be using those, even though I don't need them in my daily work, for example. And this lateral movement is also quite important concept, that an attacker might be able to move from one server to another. So that's why it's important to limit limit these permissions, for example. And then there's this concept of zero trust, which is nowadays quite commonly used, and it's also related to these previous principles with addition of these verify explicitly and assume breach. So it's good to know, at least if you're working related to identity and access management, to understand this zero trust concept. It's more like concept instead of like technology. But yeah, to remember that. And next is the cloud computing, and this explains the basics of cloud computing and some of the benefits. So good to understand those. So what kind of benefits it has might be lower operating costs, for example, and scaling when your organization is growing. Good to understand why it's so common to use these cloud services, sort of benefits it has, and related to security, it's very important to understand the shared responsibility, because in cloud computing, for example, if you're using some Azure services, Microsoft is managing some aspects of security. For example, the physical security of the data centers that we have all around the world, and the physical networks, for example. So our customers don't have, they cannot basically configure any aspects related to those that are Microsoft responsibilities, and then our customers need to trust that we are doing our best to make sure that everything stays secure. But there are still many things that they need to take care of, like monitoring their own environment and configuring the permissions, for example. And then there are these three different cloud service types, like IaaS, PaaS, SaaS. So there are differences within these, that which aspects are responsibility of the service provider and which are the customer's responsibility. So that's I think very important to understand. Yeah, so there are examples what are cloud providers' responsibilities and what you are always responsible for. And yeah, there are these private clouds and public clouds, but I think most nowadays are using these public clouds. I only have 7 minutes of time, so I will try to be quick to cover, at least on a high level, this rest of the material. Yeah, this is also continuing about the shared responsibility model, so it's important aspect of this. Then there's some explanation of Azure services and some more benefits of cloud computing. But I will skip this one to go to basics of cloud security. So it's important to understand how then in this cloud security you can be sure that you have, for example, the visibility into your services in your organization, and you have the possibility to act on any suspicious events. So this explains different capabilities we have in Azure. So for example, this Defender for Cloud, it can give you recommendations how to improve your configurations. For example, you have an inventory of different resources like virtual machines and networks that you have in your environments. And you can raise alerts on some suspicious behavior on your virtual machines, for example. So good to understand this as an example of a solution that can secure your cloud environments. And of course, there are many different products on the market that are similar, but this is something that is natively in Azure. And there are some capabilities that are part of this Defender of Cloud as an example related to, for example, network access and so on. And on the next page, we have some information about Azure Sentinel, or nowadays Microsoft Sentinel. So it's our cloud-based CM or SOAR, CM and SOAR solution. So security information and event management is the first part. So that is basically collecting logs and correlating that log data and alerting based on suspicious events. And SOAR is basically acting on based on that. So automated actions and enriching these alerts or incidents that we detect. So this explains some of the key features of Sentinel and how you can basically connect different data sources like logs from Azure or other Microsoft services and different applications or AWS cloud logs, for example, and any custom logs. And this explains how in Sentinel the threat detections actually work. So there's these analytic rules, for example, and how you are able to investigate and respond to these threats that you detect. So good to go through those. And this zero trust, we already discussed this briefly, so good to understand that as well. And ethics, well, it's good to understand at least privacy is very important concept. So not necessarily completely the same thing as security, but some of the security controls are there in place to ensure privacy. And that is, for example, explains what kind of privacy measures we have in Azure to make sure that customers' data is secure. But of course, customers in their own environment, they are responsible, for example, doing some configurations if they, for example, have some sensitive data in their environment. And then there are some other important principles, for example, accuracy and accessibility. Yeah, I think those are also important concepts. Yeah, but that was basically it for element this first units of this cybersecurity. So very important basic concepts. There's a lot of material, but hopefully I was able to highlight some things there that are important. But are there any questions or comments?
Yeah, I know we are at the top of the hour, but if there are any questions, I know there's one in the chat by Marika. In Google Chrome, browser encryption is now indicated differently than before. Is that a question, or do you want to kind of have Ilkka elaborate more on that?
Yeah, well, I have heard about this as well, that it's, it's a bit different nowadays. And I think previously it was visible quite well that if there was, for example, some certificate errors or something like this here, but nowadays it's a bit more simple view.
Yeah, absolutely. Any other questions? Okay, maybe it's a lot of content to go through and to kind of absorb. Yeah. But thank you, Ilkka, for the session. I think we were able to at least cover the most important topics of the first module of the Cybersecurity Microdegree. I again urge you all to kind of look at the course that we are following in this microdegree. The next session is on May 21st, which is going to be delivered by Romina Acuna, who is a cybersecurity engineer at Microsoft, and she's going to talk about Azure fundamentals. So some of the topics I think that Ilkka also touched upon today, we will kind of then expand a bit more on that. So please do follow the course. You can, like I said, register to the Educamu website, and if you register as a student, then you can also earn credits. There's a question, are there time limits for completing the course? There isn't any time limit. This learning circle will continue for 6 months. And you will also see Ilkka again in a few months. So probably if we have any questions for you, we'll come back again in September to you, Ilkka.
Sure.
Super. All right. Thank you so much, everyone, for joining. Thank you, Ilkka, and thank you to the Mimmit Koodaa team for organizing this.
Thank you.